Okay, Assalamualaikum and greetings to all. My name is Teacher Shafiqah, and today, before we start with our class, I would like to ask any of you are any of you aware of skateboarding before, or any of you have experienced skateboarding in real life? Actually, you can raise up your hands if you are familiar with skateboarding, right? Okay. So if none of you tried skateboarding before, I would like to share with you one story about a girl named Lisa. Okay, now you can see Lisa in one, two, three. Okay, so that's Lisa on the screen, and she's trying to become the best skateboarder in town. So she decided to utilize her knowledge in physics to actually know how much energy should be put into a system. How does each energy changes its stores, and what kind of factors is affecting her movement when she is skateboarding on the ramp? So I would like to pose two questions to all of you in the class today. First thing first, can you help me by identifying what kind of energy is involved whenever she is moving along the U ramp? And secondly, what are the factors that are affecting her speed on the ramp? Is it friction? Is it gravity? Is it mass? Okay, you can help me with that in the count of three. Okay, now take a look at the graph on the leftmost side over there. See the energy graph, and then you can see that the potential energy is at its highest, right? Okay, the blue graph is at its highest, and the green turquoise graph, which is the total energy in the system, is actually the same or at par with potential energy at the time. Okay, now let's take a look at what is happening when she is moving along the ramp. I will let her go in the count of three. One, two, three. Okay, now, yeah, take a look at the energy graph over there. We can see that the total energy is still remaining the same, right? From the start up to the end. Okay, and then you can see that, oh, Lisa is actually slowing down and becoming at rest. Right about, yeah, right about now. See? Okay. So lastly, oh, take a look at what is happening here. Thermal energy is at its highest, and it's at the same level as the total energy of the system. Now, this demonstration will actually determine our topic for today's class. Okay, so yeah, let's take a look at here. Okay, welcome back to our class. Now, this demonstration at the skate park earlier actually relates to our topic today, which is about chapter 1.7, energy, work, and power. Okay, so today we will learn about four main focus, which is to firstly identify the different energy stores, just like we took a look just now. Okay, and how is each energy transferred from one store to another? Secondly, we will use the correct equations for kinetic energy and gravitational potential energy. Thirdly is to apply the principle of conservation of energy to simple examples, and we will use the Sankey diagrams as well to apply the principle of conservation of energy. Okay, so this is the class flow for today. Just now we did the skate park activity, right? Okay, and then secondly, we will try to identify and describe each energy source. We will be using mind mapping after this, and then thirdly is to use the equation for kinetic energy and gravitational energy. Fourthly is to apply principle of conservation of energy, and lastly, and the most best part for all of you, is to complete my homework today. Okay, all right. Okay, so without further ado, here is the key definition about energy. So you can see there are seven types of energy, right? Okay, and the key definition for energy is that energy may be stored in different ways. It can become kinetic energy, gravitational energy, potential, chemical, elastic strain, nuclear, electrostatic, and also internal energy. Or just now we have watched it become thermal energy. So I will try to simplify each types of energy for you. So firstly is about the chemical energy. So foods and fuels like oil, gas, coal and wood are concentrated stores of chemical energy. So one example of energy in daily life is that, do you know that chemical energy is present in our body? So when we are learning biology, right, the chemical energy are actually produced in our digestive system. Whenever we are taking food, okay, we are taking food, and then the food is being processed and turned into energy that can be utilized by our organs. That is chemical energy. Okay, so they say that fuels can cause energy transfers when they are burned in an engine or a boiler. But in biology terms, we can see that from the example I gave earlier, our stomach and digestive system is actually working like an engine or a boiler to produce the energy. And then secondly is the gravitational potential energy, where the energy and or an object has which is due to its position on Earth. So we can see just now that Lisa, when she was at the upmost part of the ramp, she had the most potential energy. And do you know that potential energy is only affected by three factors, which is the mass, and of course the gravity pull, and also its height. Okay, M mass, G is the gravity, and H is its height. Okay. And then fun fact also for the chemical energy, batteries that you are using in your toys, maybe yeah, the compact one that you are very familiar to find in stores. Yeah, they are actually compact sources of chemical energy, which is then transferred by an electric current. Okay, and then thirdly is elastic strain energy. So elastic strain energy is just an energy that an object has due to its condition. So do you guys have any rubber bands around the house? If so, you can take the rubber band and pull it apart. Okay, give it a good stretch or compress it to where to however you want. And then do you realize that the rubber band itself has its own elastic strain energy? And then work has to be done. Yeah, like I said, you must do work to compress or stretch a spring or a rubber band, which then will convert the energy to become elastic strain energy. And then, as for kinetic energy, every moving object surely has its own kinetic energy. And the faster the object is moving, the greater its kinetic energy. And fun fact, actually, most of the people here they thought that, okay, maybe you can, when you double the speed of an object, its kinetic energy should be double as well, right? No, actually, there is a formula for kinetic energy, which is kinetic energy is equal to half of mv squared. Okay, m is for the mass, v is for the its velocity, and we know from this equation that when you double the speed, of course, the kinetic energy will increase by 4 times. Okay, due to the use of the formula over here. Now, let us take a look at electrostatic energy and also nuclear energy. Okay, for electrostatic energy, actually, uh, the electrostatic energy is just an energy stored by charged objects. So I think when you were little, you were very familiar with rubbing two balloons together, right? So let's say you take balloon A and balloon B, and then you rub it together until it produces like as if there's an electric current being transferred. Okay, so that's actually an example of charges being transferred from one object to another. and it is transferred by an electric current. This is actually an example of electrostatic energy. And lastly is the nuclear energy, where nuclear energy is just the energy stored in the nucleus of an atom. And fun fact, France is actually one of the leading countries which are using in nuclear energy to produce about 70% of its country's electricity. Okay, compared to most of the countries such as our own country Malaysia, that we still using fossil fuel. Okay, fossil fuel for our electricity generation. Okay, and lastly, it is actually about internal energy, which is also referred to as thermal energy, and this type of energy will be transferred by either conduction, convection, or radiation. Okay, so without further ado, we have learned about the types of energy stores. So sadly, that is the uh, only time that I have to spend with you today. So we will be continuing about energy transfer, okay, in our next class. Okay, and don't forget to bring your pen and pencil because for next class we are going to use this lab simulation to know about energy forms and changes, and then we will also talk about how does one energy form change to another form and what is its byproduct. Okay, so that is all from me. Thank you everyone, see you in our next class.